Hey guys, we are going to do our next video here of the next task that we're tasked with to be working with the LJ Create Kit. So again, I have everything set up here. Right hand side, you'll see right above me the programming side, and then this way. Trying to figure out my camera. Anyways, that way. Yeah. Oh, no, that one. Anyways, you get it. Left hand side, we have all the other things. So let's get right into it. So today's engineering and design task is actually coming from day 7, or this will be for day 7. So we're doing the engineering problems task, and obviously open up the hand. We're going to be building a turntable, and here's what you're going to want to do: make the turntable move slowly and stop in one spot. Mine isn't going so slowly, but I got it to work really well. Then this is what you're going to have to put in your notes. You're going to have to sketch the layout of your build. So basically, what you're going to see on this screen is what I'm going to want you to do. So I made this turntable, just kind of guessed, put it together based on the pictures I saw, and I'm not going to brag, but it turned out pretty good. So I'm happy about that. We're going to have a more detailed task I can show you how to build, and I've shown some people when we get to the next task for the turntable part. So let's jump into it. We're going to open up engineering problem task. Here it is, engineering problems task. Open up the hand, and I'm going to have it introduce it, and I'll get everything set up.
Lab work, engineering problems. One of the common outputs of an engineering control system is the motor. Motors can be used to move or rotate other objects. The speed, direction, and timing of motors can be controlled. A motor is often connected to a system of gears to change the output speed of the motor. Design and build a system that uses a motor to slowly rotate a turntable 1 revolution and then stop. Use the help sheets for assistance if needed.
All right, so here's the turntable that I created. Like I said, it turned out really nice. And let me walk you through the parts that I used. So for the base, I used just one of the really big pieces that were in the kit, and that worked out really nice. I'd use a motor, and then for the motor, I have a couple different pieces that are, let's see if we can get this in here, a couple different pieces that are holding it in place. So I just kind of played around until I found the right pieces that stuck in there. Put a little base over the one of those boxes over the motor so it holds in place. Then as far as the side goes, I used a 5-in-1, another 5-in-1, and then I used the actual motor down here for the last part. And then in the motor part, I just put a small gray little shaft, and then this spindle piece to kind of hold it in place. And then we had this piece. Now I also added on here for visual effect just this little knob, because again, it wants us to make one whole revolution, which means it will spin all the way around, and then it's going to need to stop at the same spot. We're really darn close. And the only thing we're going to have to use then is a switch to start it. So on Google Classroom, again, I started the sample tasks and pulled together a simple turntable, or turntable basic is what I called it. So what I'm going to do is I'm going to go over here, shrink down my screen. I'm going to open it up in here, turntable basic. And here's the initial setup. Now, let's talk through the flow chart that we see here and how some things might change. Well, the first thing you're going to have to do is put switch into input output 0. So I'm going to do that right now. I'll take the, actually, yeah, I'll take it off. I have a twisty tie on here. I was debating if I really want to take it off or not, or leave it on. But who knows when I need it later. So input output 0. I'll plug our switch in. And this is going to control us. And then the only other thing I see here that we're going to have to hook up is the motor. And we're going to put that into DC 0. 3, 2, 1, 0. Okay, so everything's hooked up the way it needs to be. Now, when we look at the code, let's talk about this. It starts with an infinite loop. So obviously it's going to keep running until I say I don't want to run anymore. The first thing we have to do is turn the switch or click the switch. We're going to want the switch to be set at 1. So it doesn't matter which order I have in this, but it does say switch to 1. So if yes, if it is switched to 1, it's going to turn the motor on, and it's going to turn the motor on at a speed of 75. The delay is going to be at 3 seconds. So it's going to run for 3 seconds, and then the motor is going to shut off. And if I want to do it again, all I got to do is go back up here and flip the switch. Otherwise, it'll just stay put. So what I'm going to do first is I'm going to move this over here. I'm going to take my brick here, and I'm going to plug in my USB cord from the computer. Again, we have to do these on the desktop. Okay, so it's plugged in. I'm going to download the software. It's called Program A. I usually just keep Program A in there, so then every time I redo it, I can close it out. Okay, so it's downloaded. So I'm going to unplug, go in here in the folder, find Program 1. It's loading. You may even be able to see that. I can make this bigger. And now all I got to do is flip the switch, and it should go around 1 time clockwise or counterclockwise and stop essentially in the same spot. Here we go. Whoa, okay. That was way too much, and it didn't stop in the same spot. So let me just set that up to now be at this spot. So what happened? What went wrong? Well, I think one thing is the delay was too long, and the speed was really fast. So now what we have to do is kind of play back and forth to see if we can adjust that. So the first thing I'm going to adjust, and again, this program, the way it's written, may work for a setup, but the way I set mine up, I can't use that program exactly the same. So let's just change the speed to start with. So let's just drop that down to 50. Okay, so what I'm going to do now is plug back in. Okay, this weird thing's got to go away now. Download. And as it's downloading, I'll make it bigger. So all we did was we changed the speed. Now let's see how it works. All right, still went too far, but it was going slower. And if we look, it almost stopped in the same spot, but I wonder how many times it went around. So let's count. 1, 2, 3, 4, 5. So it went around 5 times in that time period that we set. So speed didn't affect it too much, but I do like that it was going a little slower. So what we're going to have to do now is we're going to have to change the speed. Now, it went around 5 times in a matter of 3 seconds. So it's definitely spinning more than 1 rotation per second. So what we're going to have to do is find some time that is less than a second. Let's just go down to a half second. Let's see what we get. So 0.5. Okay. In, plug it in, download. Okay, let's load that software up. So again, speed didn't change this time. We sent it down to just spinning in a half a second. So we got to get this thing to spin, and in 1/2 second, it goes right back to where it is. Let's see. Open the program, loading. Here we go, commencing. 3, 2, 1. Ooh, not far enough. We're close. Close. We just got to get it there. So we needed to go just a wee bit further. So I'm just going to start putzing with things, and we're going to see what we get. So now let's try 3/4 of a second, so 0.75. Plug it in. Okay, click off to make sure that it's solid. Downloading. All right, unplug again. All right, so again, we just spread out the time a little bit longer. Wanted to go to the same spot. Let it load. Here we go. 3, 2, 1. Oh, now it went too far. You can see we wanted it to end there and it ended here. So we had a half a second before. We have 0.75 this time. So let's pick something in between. I'm going to go with 0.6 of a second. Okay. Now, if you thought about the math already, thinking it went around 5 times in a matter of 3 seconds, you probably would have been close to this time guessing or using some math to divide that out and find the rotation unit rate. So that's why I'm going to pick this because it probably is going to work. Let's see. My math was right. So everything's good. Download. All right. So we've changed the speed. We've changed the delay. Let's see if it's going to work today. You hear what I did there? I'm a poet and I didn't even realize it. I know I'm supposed to say I didn't even know it, but it was funnier that way. Okay, here we go. Let's make sure it gets to the same spot. 3, 2, 1. Look at that. We got it. Now there's a little delay, a little play in the motor, so that's okay. So there we go. We got it to go around once counterclockwise, and it landed at the speed or at 0.6. Now, do you think the speed would affect it? Do you think we'd get the same result if we slowed the speed down again? I don't know. Let's just lower it down to 25 and see what we get. Plug it in, plug it in. Download. So imagine there's people that set up massive versions of these turntables for different things, railroad companies, I don't know, bridges, you name it. Turntables are always set up autonomously or to be able to follow a motor when someone flips a switch, and they have to go through these at massive scales, as small as this to as big as maybe a 1-to-1 scale. So this stuff is tested all the time, and people do this kind of stuff all the time. So let's see what happens if we just tried to slow it down, make it a little safer, and get it to that right spot. Here we go. Oh, not far enough. Now, where did it end? It ended about there, and it started here. So if we wanted to slow it down, we'd have to just speed up the delay to make it be able to get there. So this went halfway would be here. So it went just a little less than halfway. So even doubling it, 1.2 seconds would not get us all the way. But let's see if we try this at 1.5 seconds now with the speed. 1.5. Plug this in and see what we get. And again, we're just trying to get it to be in the same exact spot every single time. So it's all about consistency when we're doing this. Okay. And again, it told us in the directions that we don't want to be going fast. We want to be going one rotation, and we want to get it to be going slowly. So I'm just trying to find a way that we can do this slowly. So let's unplug and let's try it now. Oops. Load it. Let's see. Oh, so close. So let's use just a little more time on the clock. Let's just say, let's see what 1.6 would be. So we've basically added a second to this to get it to be consistent. Let's see. I think it's nice that it's going slower and we have the right delay there. So this is working way better than going really fast and getting to that spot. Okay, finished. Unplug it in, unplug it out. There we go. Let's try it now. Oh, I was hitting the wires. Let's try that again. Look at that, right back to the spot. Again, there's a little play in the motor here. Now, to know that we have it right, we should be able to get it consistently. So let's try it at least 2 more times. Okay, again, play in the motor. Let's get that straightened out. Okay, a little play in the motor. So it's working every time, so that means we got it successfully. Great success. So now let's see what we got to put in our notes. It says, sketch the layout of your build and list the flow chart of your programming too. So we got to do two things. So if we just take a look over on the right-hand side of our screen, here is what you need to put in your notes. This, the picture you see on the screen, all this layout, and the code, which we've talked about. So now we can see what our final result was. A speed of 25, a delay of 1.6, got us to be pretty safe and got us to one whole rotation. Once you have this stuff in your notes, then you're going to go back over here and see that you have to take, you have to take the quiz. So you can back out of LJ Create and you can take that quiz here on engineering problems task and hopefully pass it. Again, if you don't, email me and I will get you what you need to be able to reset and test it again. All right, good job, guys. We're able to complete another task virtually. So I guess that's all I got for you guys. We'll see you next time we do a video.